All right, lastly here, these two examples, 6 and 7, they both use information about this one unit change. So changing the amount of something by one, and seeing how what the rate of change is based on that. So let's take a look. Effectively, what this expression is saying is this. If we take a look at a graph, and I draw some sort of curve. Let's say I'm drawing this curve. Let's say that's the function f. Then, let's say I've got some x value, x naught. So at this point in the graph, there it is. And this value right here would be f of x naught. If we go ahead and move 1 unit away, so let's say we move over here to x naught plus 1. Then we have this amount here. So here's f of x naught plus 1. If at this location we draw the tangent line, so the equation of the tangent, the tangent line might look something like this. Something like that. Okay? So now clearly you can see, although it's small, there is a little gap right here. And the red line is separated from the black curve. So there is a difference here. But that difference is very small. It's very small. And that's effectively what this thing is saying. So if you want to know what this gap is right here, this distance here, that's what this is. This is taking this y value and subtracting this y value. So this right here is the actual difference. Where this right here is using the slope of this line. That's what this is. The derivative at this location is exactly the slope of this line. So if you can imagine from this point drawing a triangle that has a run of this amount, so whatever this amount is, 1. So if slope is the same thing as rise over run, and we know that our run is equal to 1, then doesn't this just tell us that f prime of our x naught, isn't that just the rise? So that means this vertical distance right here is f prime of x naught. So you can see that this distance here and this distance here, they're not equal. But because the separation between the red line and the black curve is so small, this distance, this amount, is nearly this amount. And the closer that these 2 points are, right now they're separated by a distance of 1, but what if the separation were, 0.1 or even less than that? Then this would be pretty much identical to this. So that's exactly why we have this approximation right here. We're saying that you can approximate the difference in a function by using its derivative. So that's what a unit 1 change is. So let's go ahead and take a look here. Approximate the value of the square root of 5 minus the square root of 4. Well, to do that, we need a function to talk about. So let's go ahead, and since we're doing square roots, let's define a function. Let's let f of x be equal to the square root of x. So that's our function. Then we want to somehow line this expression up, something minus something else. We want to line that up here, try to glean what x naught is. Well, it looks like here that x naught equals 1. And we can go ahead and say that f prime, our derivative here, would be, we can take the derivative, which is 1 over 2 square roots of x. Again, I'm doing this quickly, but square root of x, this is x to the 1/2 power, And then if you go ahead and differentiate it, you would have 1/2 x to the negative 1/2, and you can choose to rewrite this as 1 over 2 root x. So don't forget about that. Okay, so this square root of 5 minus the square root of 4 is the exact same thing as f of 4 plus 1 minus f of 4. And then if this is our x naught, you can see that this expression right here is now in this exact same format. So we can then say, using the theorem above, that this is approximately equal to the derivative of f at 4, which we know what that expression is, so we can plug in 4 and have 1/4. For part B, we want to approximate just the square root of 5. Well, what we can do is take our long expression here, but just take this part approximately equal to 1/4. That's an equation. We can solve it by adding this root 4 to the other side and solving for root 5. So this would be root 5 minus root 4 is approximately equal to 1/4. So root 5 is, and again, we can just write this as 2. So this is really 2 plus 1/4. So this is 2.25. And if you get a calculator and check it, it is very close.